This is review number 6, and we're going to talk about the composition of functions. So we're going to write a composition of two functions, and we're going to evaluate a composition of two functions. So what is this phrase, composition of functions? We have actually heard this before, and we've actually used it before. And we used it in this function machine. If you kind of remember, like you plug something in and you get something out. But with a composition, what you're actually going to do is you're taking something and you're going to be plugging it in more than once, or possibly more than once. The other element about a composition of functions is you're also going to be taking functions and using them as inputs. So let's look at a quick reference just to kind of get our brain kind of on the same page here. Let's say I had these two functions. Here's my f function and here's my g function. If I know that my f function equals 3x plus 5 and my g function equals 2x minus 3. Well, if I say f at 2, that means I'm taking 2 and plugging it into my f function. So wherever I see x, it gets replaced with a 2. So that's why it becomes 3 times 2 plus 5. And then you just simplify that so you get 11. If it says g of 3, that means I'm taking 3 and I'm plugging it into my g function. So I'm replacing my x and my g function with 3. So you're going to get 2 times 3, which is 6, minus 3, which would be 3. Now, instead of thinking about it in terms of this function machine, this is the actual mathematical notation used to describe this composition. And so what this is saying here is f of g of x, which is implying, or it looks like this, which is my g function is my input. I'm plugging g into my f function. So if my f function is 3x plus 5, I'm plugging in my g function in for x. And so what that would kind of look like in that next step would be 3 and then whatever my g function is, which is 2x minus 3, and then plus 5. And then obviously we'd go through and simplify that. But we're going to look at that in a few examples here. So just remember, a composition just means we're taking a function and we're plugging it into another function. That's the basic implication. So let's look at this. Here's my f function, here's my g function. And it says g of f of 1. So this is what it means. So we have to work at it bit by bit. And so this says take 1 and plug it into your f function. So if I take 1 and plug that into my f function, that gives me 1 squared minus 4 times 1. Here's my f function, and I'm plugging in 1 for it. So I'm going to get 1 times minus 4, which is negative 3. So then f of 1 is negative 3. So that means this is going to look like g of negative 3. So now it's saying take negative 3 and plug that into your g function. So here's my g function. I'm going to plug negative 3 in there. 2 minus the square root of negative 3 plus 3. So 2 minus the square root is 0. So 2 minus 0 equals 2. And that's my answer. This next one, it says f of g of 1. So this is the same thing as that. It's saying take 1 and plug it into g. So if I take 1 and I plug that into g, I get 2 minus, here I'll just write it off to the side, 2 minus the square root of 1 plus 3. So 2 minus, that's the square root of 4. The square root of 4 is 2. 2 minus 2 is 0. So I know that g of 1 equals 0. So this is now f of 0. So take 0 and plug that into my f function. So if I take 0 and plug that in, I'm going to get f of 0 equals 0 squared minus 4 times 0, which is 0. Now, we could write just 0, we could write just 2. the formal way of writing this would say f of g of 1 equals 0. Because there's more than one way for us to be able to get 0, or at least there's a possible means for us to get 0 in other manners. Now, what happens if we're not using any variable or any like specific explicit value like 2 or 5 or 10? What if we're only using variables? So what we're going to do, we don't need to worry about the domain part. We'll punt that later. But for now, this is saying g of f of x. So this is saying take my f function and plug it into my g function. So if I take my f function and plug it into my g function, that means I'm going to plug it in for x. So I'm going to get 2 minus the square root. Now instead of x, it's now my f function. So that's x squared minus 4x, and then plus 3. And so I get 2 minus the square root of x squared minus 4x plus 3. Now, if there was ways for us to simplify it, we could simplify it, but we can't. We can't simplify it anymore. No, the square root does not cancel out with that x squared. The square roots only cancel out with perfect squares. We're going to go over that later, but just know that this does not simplify anymore. This is it. So I could say g of f of x equals that. So now let's look at b. This says f of g of x, right? Which is that. So this is saying take my g function and plug that into f. So that means, let me erase this to make it a little cleaner. I'm going to take whatever my g function is, and I'm going to plug that in for x into my f function. So that means I'm going to get 2 minus the square root of x plus 3 squared minus 4 times 2 minus the square root of x plus 3. Now the only thing that I noticed that we can kind of clean up is just this one for now. So I can distribute that negative 4. So I still get 2 minus the square root of x plus 3 squared, and then minus 8 plus 4 times the square root of x plus 3. Right, because negative 4 times negative is positive 4. Now, yes, we could simplify that, but we don't need to worry about that. This is good enough. This is the basics of what we're kind of trying to talk about in terms of composition of functions. We're just taking a function and plugging it into the other function. So what did we learn today? We talked about the composition of functions, which is basically taking a function and plugging it into another function. And we can have a string of them. And I know we didn't really talk about it too much, but technically if I said, f of g of h of x, this means you're taking your h function, you're plugging it into your g, and then whatever you get with that, you're going to plug that in to your f. And you can do that with a massive string of functions. This does conclude our lesson. If you have any other questions, please leave them in the comments.